4.1 Radian and Degree Measure. What you should learn: how to describe angles, how to use radian measure, how to use degree measure and convert from one to the other, how to use angles to solve real life problems. First, angles. If you remember from our geometry, an angle looks like this. This would be angle ABC or angle B. And this angle in the middle right here, that's our angle. And we can figure out how long it is, how wide it is, and stuff like that. In Precalculus and above, we're generally going to think of angles on an XY coordinate plane, where we can start at 0, or let's just say 0 right there. And that's going to be our initial side. And then however the angle opens up, where it ends is our terminal side. So that's going to be our angle mapped onto a grid. So there's two ways you can open. We can open up or down. If you open up, we call it a positive angle. If you open down, it's a negative angle. You can see that here. It's opening up, it's opening down. And this will just be the negative angle down there. Counterclockwise is positive, clockwise is negative. You can keep on going also. If you see this, the B here, it goes around in a circle and then keeps on going up again. Angles go on for as long as you want. We'll talk more about what that does in the future. How do we measure angles? There's generally two ways, and we're going to start off with degree measure. The degree measure is probably the one you've seen since like grade school. You can use a protractor to measure it. Here's our angle again. There's our vertex. We start at 0. That's our initial side. And then this is our terminal side. On an XY grid, it looks like this. Here's our X. Here's our Y. If you notice, an XY grid, it's a rectangle. This is a right angle, which makes this straight line appear at 90. Kind of like the straight line here. And then if you do another 90, you get 180. If you go another 90, you get 270. Another 90 is 0. That's a standard degree measure in XY plane. The first thing is, do we know how to draw an angle there? So let's draw a standard angle of 230. This is a quick sketch. This is 0. That's 90. This is 180, 270, and then 360. 230 should be somewhere in between here. Does not matter. Then remember, we start off from 0. This is our angle 230. All I really care about is you get the correct quadrant. Quadrant 1, 2, 3. You should be right here. Quadrant 3. Coterminal angles. Coterminal angles are angles in the same position, just a different measurement, like higher measurement. Right here we have 230s right there, but if I had an angle that went around and landed back the same spot, those would be coterminal angles. Easiest way to find them, just add or subtract 360, because 360 is a full rotation. Coterminal angle to 230 would just be 230 plus 360, which would get me 590. Those two will be coterminal. You can also go backwards to subtract 230 and have a negative coterminal angle. So for this one, we want to find a coterminal angle to 400. So I'm just going to go, I can just add or subtract 360. Let's subtract 360, and I get 40. 40 and 400 are coterminal. If I would graph both of them, here's 0, here's 90, 180, 270, 360. Let me graph 400 first. We go all the way around to 360. You're like, ooh, I'm not done yet. But how much more do you have left over? I have 40 more because I went 360. To go a little bit higher, and that's 400, but it's also just the angle 40. So when that happens, those two things are called coterminal. And the way you find them, just add or subtract 360, because you just do a full rotation. So that's degrees. That's one way to measure. That's probably the one that most people are comfortable with. They've been doing it since like they're younger. We have another way to measure, which is called radian measure, and we use this one much more in calculus. And it's a measurement based on the central angle and the radius. That's where it comes from. We call this radians. So the way a radian works, it's just like a degree, because they both are measuring angles. Here's my little degree sign. We start at 0. Radian starts at 0 also. And then you go up to 90. In this case, it would be pi over 2. Then we go down to 180, which is equal to our pi here. We have 270, equal to 3 pi over 2. And then we go back to 360. A full rotation is 360 degrees. In radians, it's 0 to 2 pi as a full rotation. Half of your full rotation is just pi. Half of that, pi over 2. And I like to think about it, you're just counting by halves. 1 pi over 2, pi. Then we get 2 pi over 2, which is the same thing as just 1, so pi. 3 pi over 2, and then 4 pi over 2, which is the same thing as 2 pi. When you do radians, it's all about the fraction. Let me explain it to you a little more. I'm going to want you to draw a standard angle in radians of these guys. And it looks daunting at first. A lot of people always want to convert it. I'm like, you don't have to convert it. All you do is this. Here's 0, here's pi, and 2 pi. And the key is the common denominator. That's the key. You want to think common denominator. This is 2 pi over 3. So what I'm going to do, here's pi. I make this 3 over 3. And that makes this 6 pi over 3. 6 over 3 is 2. Just go 3 over 3, another 3 over 3, 6 pi over 3. Where's 2 pi over 3 at? Remember, if we're going positive, we're going up. Well, if we get to here, that's 3 over 3. We're not there yet. We're a little short. You're just in the quadrant right before it. You start here, and we're going to end here. That's 2 pi over 3. Is that angle. Because all here will be 3 over 3. We haven't got there. We're a little short to go up 1, 2 pi over 3. That's the way I sketch radians. So let's look at the next one. Here's 0, here's pi, let's say 2 pi. This one's negative pi over 4. So this is 4 over 4. This will be 8 pi over 4. 4 over 4, another 4 over 4 will give me 8. 8 over 4 is 2. Negative, you go down. Anytime you don't see a number, it's a 1. Basically just going down, negative 1 pi over 4. We're going to go down. We start here, we go down. Anytime it's a 1, it's just in the first quadrant. So in this case, since we're going down, it's quadrant 4. So this would be negative pi over 4. Anytime it's a 1 on top, normally you just go up, but it's the negatives going down. It looks like that. Next one, draw an angle in standard form of 7 pi over 6. Same idea. Here's 0, here's pi, here's 2 pi. We're talking about 7 pi over 6. I'll make this 6 over 6, and I'll make this 12 pi over 6. And then 6 is 12, or 12 over 6 is 2. I want 7. So from here to here is 6. I'm not there yet. I gotta go a little further. I gotta get to 7. So I go a little bit past this. It'll be the very next quadrant. So we start at 0. This is my angle of 7 pi over 6. And then right here, we want 8 pi over 3. We're gonna do the exact same thing. Here's 0 pi, here's 2 pi. 8 pi over 3. This is 3 over 3. This is 6 pi over 3. If you notice, I don't hit 8. This is 3. This is 6. I could get 5 if I go a little less. I could get 7 if I go a little bit more. I gotta get more. I don't have 8. We just keep on going. 3, 6, 9. And I could go 12 and 15. I can keep on going around. Where's 8 at? 3, 6, 9. 1 short of this quadrant. That would be, we started here. If you want to be technical, we went around in a circle. And we got 8 pi over 3. We have a coterminal angle there with 2 pi. Do that. Let's do one more. Let's do pi over 6. Anytime there's no number on top, it's in quadrant 1. So here's 0, here's pi. It's just going to be in here. Pi over 6. Anytime there's no number, it's in quadrant 1. Unless you get pi over 2, because don't forget, pi over 2 is the middle. If I give you pi over 4, it's in quadrant 1. Pi over 2 is halfway. Okay, let's sketch and find coterminal angles. Remember what coterminal angles were? We just added or subtracted 360. What's going on here though? We're in radians. How do we take care of that? Same concept. We just add or subtract 2 pi. Remember, that's our 360. 360, 2 pi, same thing. We have 13 pi over 6. All we're going to do is subtract. We want to find a positive angle of this. We're going to subtract 2 pi from it. Now here's the key. Make it a fraction. Hopefully you're good at fractions. That's all we're doing. We're just going to subtract 2 pi. Just make it a fraction. 2 pi over 1. We need a common denominator. Well, this is 6. So let's multiply this by 6 over 6. 2 pi times 6 is 12 pi. I'm going to rewrite it just for your guys' sake. So 13 pi minus 12 pi over 6. And I get 1 pi over 6. If I want to graph it, remember, anytime it's a 1 pi, anytime there's no number on the front, it's just quadrant 1. I could also done it by doing 13 pi over 6. It would have been 6, 12, and then a little past. Exact same spot. Right here we have a negative number. We want a positive coterminal, so we're going to add 2 pi to this. Again, if you know how to add fractions, you should be golden. So we're going to add 2 pi. All we're going to do, common denominator over 1. We're going to multiply this by 3 over 3. This will be 6 pi. Negative 2 pi plus 6 pi is 4 pi over 3. If we want to graph that, I'm going to go 0. I'm going to go pi, 2 pi. You know me, I like to use a common denominator. Let's make this 3 over 3 and 6 pi over 3. Where is 4 pi over 3? We start here. And we're going to go up. There's 3 over 3. I got to go a little past that. 4 over 3, the very next quadrant. That's 4 pi over 3. We went this way. Now, we could just graph this one, honestly. We're pro at this. If I was going to graph that one, here's 0, here's pi. Keep in mind it is negative, so we're going to go down. This would be negative 3 over 3 and negative 6 pi over 3. Negative 3 over 3 is there. We haven't reached it. We're a little short on that. We can't get all the way to negative 3 if we're a little short. It's right here. The exact same spot. So this is going the negative version, and this is going the coterminal way. So you get the same spot either way. What if you want to convert? What can be done? Here's a shorthand for it. If you want to go degrees to radians, all you're going to do is you get your degree, and you're going to times it by pi over 180. We'll get you the radians. Now, how do I remember it? I remember radians. If you look at radians, they always have a pi in it. If you're in degrees, if I give you like 20 degrees, you don't have a pi. You need to get it back to put it on top, and you put it over 180. That's how you convert from degrees to radians. You want to go the opposite way? You want to go from radians to degrees? Well, now you have a pi. It's to be like 4 pi over 3 or something, most of the time. Not always. But you're just going to get your radians, and you're going to multiply with that reciprocal. You get rid of that pi. So it makes the 180 on top. That's how you convert. My general rule, right? If you have a pi, you want to get rid of it, so you put the pi on the bottom. The ratio is 180 over pi. I just remember if I have degrees and I want radians, I need the pi on top because I want a pi. If I have a radian, I'm trying to get rid of that pi that's on the bottom. In general, also keep in mind, if they don't put a degree sign, the implication is it's radians. If you just see 2, 2 means 2 radians. Or you just see pi, that means pi radians. Okay, it wants to convert this from degrees to radians. I'm going to get 135. I don't have a pi, I'm going to multiply by pi over 180. I get 135 pi over 180. Then you are supposed to reduce it. They both divide by 5. I'm going to get 27 pi over 36. And actually I could divide that by 3 and I'll get 9 pi over 12, which I could divide by 3 again. I get 3 pi over 4. But if you want to convert from degrees to radians, you can do it that way. But if you want to go backwards, what if you have radians, you want degrees? I just think, okay, I have a pi, I want to get rid of it. So I'm going to multiply by 180 over pi. Nice thing here is the pi's cancel. You get negative 180 over 2, which is negative 90 degrees. If I give you 2 rad, so that's just 2 radians. They tell me it's rad. This still has a pi, you put on the bottom, over 180, and you get 360 over pi. And in that case, you're supposed to divide with your calculator to figure out what it is. 360 divided by pi. There's a pi button right there. You gotta put second pi. And we get 114.6, we'll say. By the way, you can also use it over here. Let's say we want to convert 540. So it would have been 540 times pi over 180. I'm not going to put the pi. Let's put 1 over 180. The pi will get messed you up. You want to leave it in terms of pi. So you get 3. This will just be 3 pi. Or just leave out the pi, because the pi will get you some decimal, but you want to keep the pi into there. Okay, so how about complementary, supplementary angles? We should know complementary angles are 2 angles that add up to be 90. Supplementary angles are 2 angles that add up to be 180. If possible, find the complement and supplementary of each angle. Well, I mean, A, we're just going to do 2 of these. We'll do A and C. Well, if you want the complementary of A, that's just 90 minus 72. It equals 18 degrees. What plus 72 gets me 90? Supplementary, same idea, but it's 180 minus 72. But that's going to be 108. What if I do C, though? It's in radians. Complementary, basically it's the same idea. But what's 90 degrees in radians? That is pi over 2. We're going to do complementary. We're going to do pi over 2 minus pi over 5. And it's really just, how good are you at fractions? It's really the question here. So I need a common denominator. Let's multiply this side by 2 over 2, because it doesn't have the 2 in the bottom. And multiply this side by 5 over 5. I get 5 pi over 10 minus 4 pi over 10. And I get pi over 10. So if you're good with your fractions, not a problem. If you kind of suck at your fractions, a little bit of a problem. Supplementary, it's 180. What's 180 in radians? Pi. Pi is 180 in radians, so we're just going to do pi minus 2 pi over 5. Easier common denominator, though. Over 1, that's going to be, what, 5 over 5? We get 3 pi over 5. That's how you do complementary and supplementary. Let's talk about linear and angular speed. First, we're going to talk about arc length, which is exactly what it sounds like. It's how much of the arc, how much of the circumference are you taking up? Well, that does relate to radian measure. That's why we use it a lot in calculus. And if you just manipulate the equation a little bit, you get the arc length formula, which is just S, which is the arc length, equals R theta. R is radians, radius, that I meant, and then theta is radians. The angle in radians, is to say. Now, it has to be in radians. In degrees, it's a totally different formula. I mean, it's the same type of formula, but it's in degrees, so it changes a bit. This simple formula only works in radians. It has to be in radians. So let's go here. A circle has a radius of 4 inches. Find the length of the arc intercepted by it. So we're going to try and find the length of this arc, the angle of 240. So our formula is this, R theta. And we have R is 4. So it's just 4 times theta. But again, theta is not 240. You got to turn that to radians. This has to be in radians. So we have 240. We got to change it to radians. But that means I want pi. That's on top over 180. We could do that or put in our calculator. Let's show you how to do this in a calculator if you want to do that. 240 divided by, remember, leave the pi out of it, for 180, and I get 1.333. That's also 4/3, but whatever. What if you want to make the calculator do that? You go math, fraction, and it'll turn into a fraction for you. 4 over 3 pi. I'll put that in. 4 times 4 over 3 pi. That's over 1, but I get 16 pi over 3. I always cover my work. And that's how you find arc length. Just keep in mind it has to be in radians or angle, but that's the lesson.